And so then we just want to make sure that we've got the correct vessel type selected, which we do. We want to make sure that our carrier's out to start with, and we'll hit OK.
The slide label was on the inside or the outside?
It was on the outside.
The outside, okay.
And it's upside down.
Upside down.
Yeah. So we've got DAPI staining, right? Some sort of nuclear stain.
I think she said that.
That 488 and 67.
So it should be all three.
So you put find image to find the image.
Yeah, find image, it will just bounce between exposure and an autofocus routine real quickly. And it seems like it found something.
And you
well.
said this pattern is exactly what we want. Something like this
Yeah,
kind of
you want
tapers off.
You want it stretched across this whole one, just like in that document that I showed you. So
Okay.
this is your background peak. This is your different levels of fluorescence in your sample. And then this little spike at the end is just these few really bright pixels that are slightly overexposed. But it's perfectly acceptable to have a small spike out there. This is just 4x, so I'm just on zoom in so we can get an idea if it focused pretty well. And that looks like it focused really well for it being an unknown slide and everything. So we'll just grab this.
And if this was out of focus, that's when we would go to the FM scan.
So if this is out of focus, we'll go to FM scan.
Okay. All right.
We'll try, let's try your DAPI. So you notice it's keeping the same field of view, even though I'm zoomed in. This is the full image again. So it looks like the GFP and the DAPI staining are pretty much overlapping, but this is looking a little bit dimmer. We got a lower exposure here. So let's hit auto expose and see what it determines is good for exposure. So you see it brightened that up quite a bit, got a good range, small spike over here, but that's fine. But you see we got a little bit of background here. That's okay. You can. That's mostly from the monitor trying to display it, because it's converting a higher bit rate to an so a 16-bit camera to an 8-bit monitor. So when you change brightness and contrast, which I'll show you here in a little bit, that changes how it displays on the monitor, not your actual data. So again, let's go in here and look. That looks pretty decent. Our LED intensity is pretty high, so we might photo bleach our samples if they're really sensitive. But we'll go ahead and capture that.
You don't want it. You shouldn't take it down.
You can. So we could, if photo bleaching was more of a worry for us than background, we could decrease our LED intensity and we could increase our camera gain. And you see the noisiness, like the static nature, it becomes grainier. But we're able to use half the LED.
What was the integration time? One more time.
The integration time is how long it's exposing the camera to the light from the sample for each image. So here it's pretty much taking a second for each one.
All right.
So let me go to Texas Red now, see what that looks like. We might be not have optimum exposure here.
We have Texas Red on there?
Alexa 607.
We do. Okay, so okay.
So let me hit auto expose.
There's no APC channel?
This is as good as it's going to get.
Right.
Yeah, based on the accessories that you've purchased, these are your options. So it looks like we've just got a few cells that are positive for that. So let's look in here. And it looks like, yeah, we've got some. They look relatively in focus. But we'll go ahead and capture this image. But you see it's straining really hard to get this image. So it's got everything cranked up to its highest. But that happens whenever you've got very rare objects in there. It strains to try to see more. So we've captured our 3 images. Then we can just go to review and save, and we can look at them as a composite. So you see here's all 3 channels together. I can just look at the GFP if I want. I can look at the DAPI. I can look at the DAPI and the Texas Red to see if it's associated with cells or not. I can go up to my zoom and zoom in here, and I can toggle back and forth. So let's look at my DAPI. So I've got brightness and contrast up here. Again, this only affects how it's displayed on the monitor. I can crank up my brightness to see a little bit better. And you can see how your histogram moves around as you adjust the brightness and contrast.
Okay. And that's not what you want, right? You do want it to taper off a little to bring up the bright and take
Honestly,
away the...
this portion is just for your visualization on the
I
monitor.
see.
It doesn't, your image is already acquired now. All that data is captured and fixed. You're just changing what it's using to display it on the monitor. So this is more visualization. This just kind of helps you gauge. So now let's do Texas Red, and we see that it is associated with a fainter blue blob here, so it is associated with the cell. I can go down here and switch to Texas Red, and I can adjust the brightness and contrast in that separately. And let's say I turn on the GFP too, same thing. Go in brightness and contrast, go to GFP, and then I can crank down the brightness a bit, crank up the contrast, and reduce the background a little
Well,
bit.
this is your post-acquisition mode that you can do in any software, pretty much, right? Photoshop, anything could do the same thing, kind of.
Yeah, this isn't manipulating, like in Photoshop you'd actually be manipulating your image file. Here,
Yeah.
it's a TIFF image.
I see.
All this is doing is
Yeah, I
changing
see.
how it's translating it from 16-bit information depth
Yeah.
for your colors to the probably 8-bit monitor. You see we got background in our Texas Red now, so I can go up to Texas Red and I can decrease the brightness to get the background to be more black. Let's go back to GFP. So now we can see all three overlaid. Now we could do an analysis and set it up to count these objects and then to count what population is red here. But first we want to consider maybe saving this. And again, all of this is if you're just setting up things initially, or if you're just wanting to acquire just a few images. You'd go into experiment mode and set all this up if you were wanting it to automatically acquire like a 10 by 10 montage of your slide automatically. If I go to save here, you can save these images as either separate TIFF files. So save image raw data, multi-channel image, save channels as separate files, so it will create one for DAPI, one for GFP, and one for Texas Red, separate TIFF files. Or you can hit stack all images in a single TIFF file, and it saves them all in one stacked TIFF. So it's pretty much the same way, except whether you want it to be separate files or together. So these are large TIFF files that can only be opened by, scientific style software like ImageJ or Gen 5 here. But you can also hit Save Picture for Presentation here. So if we do this, it will just save it as a generic image type that you can plop into PowerPoint or something like that for any type of presentation or document. So let me hit Save Image Raw Data, and I'll have them save all of them as a single TIFF file. I'm going to hit OK. Now let's just name it. So this is
Celine.
4x, 4x,
Celine.
maple.
That's right.
It's network, so you can get to wherever.
So when you save them all as a stack, does that mean you can't separate them?
So you can't separate them now. So if I go back here, so
Yeah.
you see we're looking at our image. I can go up here, instead of hitting camera,
Yeah.
which will capture this image,
Yeah.
I'm going to go to dot, dot, dot. Now where did I save that at? I don't remember where I saved it. Well, I'll open up this one because I know where I saved it. So this is my 20x sample slide that I took yesterday. So that's just one single TIFF image. And you see I've got all three here.
I see.
So then I can go to Review Save, and I can look at these archived images. So I saved this in the exact same way, but I paid attention to where I saved it. But this is the same thing. So now I could go on to do analysis on it still. So I hit save. Let's see where we're going here. Gen 5. Oh no, I'll have to look around to see where I put that last one. But same sort of thing here. If I hit Analyze, let's turn off GFP and Texas Red. Then I can go up here to do different types of analysis. Image statistics, it will just look at the whole image and tell you like what's the average intensity for this whole image. How much DAPI staining is in this whole picture. Cellular analysis will go through and look at individual objects. So here we can select a channel. So I selected cellular analysis, and I'll select the DAPI channel. And then you can set various parameters like image size, like object size. So this would be the diameters of your various objects. So if I select my zoom and I zoom in here, then I can select this line tool and I can slide across here. And you see this is my cross-sectional profile of my image. So this is intensity, and then this is the length across my line. And so you see this is my object here. So you see it's got one bright spot around there. And it automatically calculates the width for you, so you don't have to. And it shows you how bright it is. The background here is the bottom 5% of your pixels inside of the image. So you see where it drew the background line. So our background is around 3,400 in intensity. And our peak up here is above 30,000. So if we set our threshold here at 5,000, it will go at 5,000 above background and consider any pixels above that that are amassed together in an object that is between 5 and 100 microns in width. It will consider that as an object and count it as a cell. But 5 and 100 is that's a pretty broad range. But let's see how it works. So let me just exit out of this here. I'm just going to hit start. So you see it did a pretty good job.
Mm-hmm.
So we had it go to pretty small object sizes all the way up to very big ones compared to what our real objects were. And our threshold, we just went with the generic 5,000, but you see it was able to accurately identify each of these objects and find its edge. And if we, let's go down here, if we turn off highlight objects here, we can see how closely it put the line to the actual edge of the dappy. That's looking pretty good. So we could increase this threshold here. We can set it to like 20. Let's do it as 20,000. Let's hit start and see what it does. So you see all these objects are too dim now. So they might have pixels in them that are above this threshold. So that would be, that plus the background, that'd be like 23,400. So they might have pixels that are brighter than that, but there's not enough of them lumped together to be a continuous object between 5 and 100 microns in size. So it doesn't count those. I'll grab my hand tool and I'll drag over here. But you see, these were bright enough. But if I turn my highlight object on and off,